Normally, when Katie and I talk with people about data centers, it tends to be the commercial real estate side of it and investing in it, but you actually develop these things and actually install and operate them. So give us a sense of what's the big deal with data centers now that didn't exist before the rush to AI? We've had them around for some time, right?
Yeah, David, I think that the key to understand, the primary thing to understand is the difference in the compute workload that's going into data centers now versus what it was in the past. So in the past, we were building data centers that were in population centers that were providing ultra low latency communications so that we could get YouTube, so that we could get Netflix, so we could get TikTok, right? So we could get all of our things that have been driven mostly by video applications. Now, as we're moving from applications that need ultra low latency communications outside the data center to applications that need massive amounts of compute. So think of it, doing large math problems, algorithms. This is what AI is doing inside the data center. Compute equals power. And then inside the data centers, you need a lot of compute close together, so you need really high power density, and so these are kind of some weird numbers, but historically data centers were, let's call it 7 kilowatts for an entire rack of computing. An NVIDIA H100 server, one by itself takes 10 kilowatts. And then you need to stack all of these together. So you have a massive amount of power consumption that needs to be close together. The latency inside the data center now versus outside needs to be ultra low. And so you have to build a completely different style of data center. You need large amounts of power in the same location. And so that's what we're doing. We find large amounts of power, typically different locations than you would do city centers. So it's no longer New York or Virginia or Dallas or Los Angeles. We're building in different locations where we use a lot of renewable energy that have these hundreds of megawatts, if not gigawatt of power, so that you can, run these workloads, because they're just very different style workloads versus what we're used to.
Right. And when it comes to that adaptation process, really sort of converting those existing data centers to be able to handle the AI workload that people are trying to do, I mean, how long of a process is that? How long is that timeline?
So I'm a big believer that you're better doing greenfield, in that you just build an entirely new style of data center versus trying to retrofit. Cooling is different. Again, the power density is significantly different. So there's a big issue. So the number one issue right now is finding power. Where's near-term power? We have a very unique way of finding power, which is we find things that are called stranded power, and we typically use a lot of renewable energy that's more in the middle of the country. So number one is power, and then number two is supply chain. So this is electrical components. This is, it's transformers, it's chillers, it's high voltage switchgear. So the supply chain, because of the demand for this, has become really stretched as well. So number one is power, and number two is supply chain.
So Wes, are you building your own power? I mean, you're building those wind farms or solar or even nuclear for that matter, or are you tapping into some other part of the grid? And similarly on the supply chain side, how long is the lag time on all this? It sounds like it's going to take an awful lot of time to build that power and also come up with all that supply chain.
So right now we're not building the power. That's something for the future for us. So there's a unique setup in North America that we take advantage of. What I call it is stranded power. So there's power that is generated and not used. And I know a lot of people would think that if you can generate an electron anywhere in the U.S., it can be used anywhere else in the U.S. And that's just not the case. You need the transmission infrastructure to actually be able to do that. So we find places where, for Ellendale, North Dakota, for example, there's a massive amount of wind power that feeds into a substation. And oftentimes they have to curtail the wind farms because there's not enough demand, there's not enough load to use the power that's generated. So we go to that location, and we have several of these locations where we use power that's currently not being used. Now, to go to the other part of your question is for new power. So you can build power gen on renewables over, let's call it a 24, maybe 36-month time frame. The bigger issue is transmission. So transmission to transmit that power that typically is built, somewhere in the middle of the country to end users, that's more of a 10 to 13-year process. And so we're kind of shortcutting that by taking these workloads directly to the point of generation.
And I want to talk about the competitive landscape here, because you think about AI and it's just really made its way into every part of the market. It seems like every investor in every asset class is trying to figure out what's the AI narrative in their industry. When you think about your own industry and data centers right now, how fierce is the competition?
It's an interesting time for sure. So if you go back a year ago, everyone was trying to figure out on the data center side what's happening in this market, right? Why is all of this demand? Why for the high power density? Now, in this industry, we figured it out, and now it's trying to make this solution because, again, getting the amount of power that's needed and operating these style of data centers is extremely difficult. And so think of on the data center side, we're the picks and shovels. This is digital infrastructure. This is the digital infrastructure that was built out to run everything that everyone's used to running on their phone or on their TV at home, and now it has to be rebuilt. It's not a replacement, by the way. This is an add-on, but rebuilt for compute and AI workloads. So we're the building blocks. We're the infrastructure that runs all the AI that everyone wants to do. And we're talking about everyone knows ChatGPT, but if we're doing anything in video, in visual, anything generative AI runs on this infrastructure, and a massive amount of this infrastructure needs to be built. When Jensen at NVIDIA talks about AI factories, so what we've done, we actually designed our data center in partnership with NVIDIA. We work with their team to build the style of data center that we're doing, because this is the issue in the data center industry, is it's just a very different style from data centers that were done in the past, but we're running all AI workloads, and these are really split between training and inference are the terms that are used in AI, but the entire industry is, I would call it, scrambling to build the amount of infrastructure that's needed to house the compute to run these applications.
Well, it wasn't that long ago we hadn't even heard about all these data centers. What's going to prevent obsolescence?
So that's a great question. So when we build our facilities, we think about what we call future proofing, right? So we think the power density goes higher, cooling. But I think the last 20, 30 years were, again, really driven by applications that required, I call it comms, high-speed communications. And as we go for the next 20 or 30 years, applications are really going to be driven by compute. And that's what AI is. And so we're, working to future-proof that. And by the way, the older style data centers, those are not obsolete. We still need all of that capacity for the applications that we continue to use. This is absolutely a complete add-on to what's been done in the past. And so, but trying to not be obsolete is making sure that you're future-proofing your facilities as much as possible with power density, with cooling. We're trying to run it at extremely high efficiency so that we lower our carbon footprint. We build where there are renewable, right. We mostly use renewable resources, but those are the things you try to do. Obviously, not being obsolete in the world is one of the keys here.